back. Hello, everyone. Long time no see.
Yeah. Just a little bit of housekeeping before we get started. If you're following our program, you will be expecting Zaid Ashgar from Qualcomm. Unfortunately, he was tested positive for COVID a couple of days ago. He's feeling fine, but couldn't make the conference, so therefore we've had to shuffle a few things around this morning. But I think that's just going to give us a little bit more time to talk.
Awesome.
So I think it's going to work out just fine. So, a lot of people heard you speak yesterday. One of the things we didn't talk about yesterday that I think we can do today is just explain a little bit about your path in technology. How did you find your way into AI and sort of find this career and this path?
Yeah, so I have probably the most unconventional background out of any other published AI researcher that I know. So much like an algorithm, when I was a kid, I grew up in a really bad neighborhood, had a lot of bad data into my life about what success meant. So bad data in, bad choices out. By the time I was 16, I was in juvenile hall facing 27 years in prison. Ended up getting blessed, getting a deferment program, didn't do that. So I ended up, taking care of what I had to, rectifying the harms that happened, and then saying, I want to never be involved in any of this kind of stuff again. I want to get as far away from this as possible. So I dropped out of high school, started community college, got my life together, taught myself how to code. In fact, one of my mom's friends actually bribed me to learn how to code. He was like, you're too smart for this. He put this book on the table, spread $1,000 on it, and he was like, if you do every exercise in this book, I'll pay you. And so halfway through, I was selling websites, and I haven't looked back since with tech. Probably I was like 19, and I got accepted into UC Berkeley. And I said, yo, I do not have the discipline to succeed here. How am I going to make this work? So I called my older brother, who was in the Marine Corps. He ended up retiring from the Marine Corps. He said, join the military. Like, they'll help you get your act together. You can serve your country, make right what happened when you were younger. So I did. And so between my junior and senior year at UC Berkeley, I was deployed to Afghanistan. I went to the headquarters of all special operations for U.S. ISAF and NATO forces, worked with Tony Thomas, who went on to become the 4-star commander for all of SOCOM, so big deal. Out there was when I got my first taste of artificial intelligence. When I was in Afghanistan, I worked on computer vision systems. I worked on NLP systems. When I came home from Afghanistan, I worked for various consultancies, working in mostly the NLP space, so language AI. And so this general called me up and said, hey, come out here to Japan. Like, I need your help. And I was like, I don't want to move to Japan. He's like, well, it's a tropical island. A week and a half later, not even 2 weeks, I was in Japan. So I did some AI for the US and Japanese government around auto translation before Microsoft recruited me. I spent time in their national security group, which is basically, I was a Microsoft employee that was rented out to all of your favorite 3-letter agencies, your FBI, CIA, NSA, DIA. Then I went to their innovation unit where I basically worked on smart environments, what we were calling ambient intelligence. So how do you merge technologies like blockchain, not crypto, the underlying data store, blockchain, AI, and IoT together to fully automate an environment? And so I'm actually credited with helping companies like Xbox, Bank of America, Singapore Airlines, Nestle figure out how to combine those technologies and make them useful. Before going to Google, where I worked across various roles in responsible AI, responsible innovation, so helping Google clean up its own house, if you will, across all of their algorithms, research papers, across all of the nonprofit deals that they would fund, the deals that they would allow in Google Cloud, before starting 2 of my own research teams at Google, one of which I mentioned last night. The skin tone research team, which basically taught AI how to see black and brown people. And so we gave that solution away to the world for free. And now I am up here talking to all of you. So that's my background.
Nicely done. So let's start. You talk about garbage in, garbage out in a personal way. Having spoken to you about algorithms and the state of AI today, I mean, you really think that that's where we are in the current state of the industry, that it's being built on bad data sets. Can you just talk a little bit about how big a problem that is?
Yeah, so I think one of the challenges is that bias can happen at any point in the system. But it all starts with before the data set you collect, with how you decide you're going to solve the problem, right? So an example of that is there was a research paper that came out of Stanford, I think 2018, 2019, where these gentlemen had decided that they were going to try to teach an algorithm how to look at a picture of your face and guess your sexual orientation. So the first thing is, why would we even do that, right? Like, that's the first place bias can enter. So the way in which we decide something is a problem, and the choice to use AI as a technology can be problematic. But then once we decide that, how we go get data to represent that problem can actually cause the entire algorithm to fail, even if we have the right intentions in solving it. So I think I talked about this a little bit last night. You take PredPol, which is the predictive policing software that all of these police departments are using, right? They take historical crime data from an area and predict where crime is going to happen next. Well, if you look at any other discipline besides computer science, there's a lot of research that already shows that that data is skewed in how it's collected, that certain groups are more likely to be let go by police, that police already spend more time in certain neighborhoods than others. So the data that's going in is already skewed, so it's essentially telling the cops to go hang out in those same places, even though that might not be where crime is likely to happen. And so now we're wasting police resources even more, right, by telling them, well, here's an algorithm that tells you where to go, and it's telling you to go somewhere that crime isn't happening. Another example of bad data in and bad data out, and I know we're going to get into this a little bit more, is when you think about these models that are being built on top of massive data sets, right? So whether that's a large language model like ChatGPT or BARD or Claude, or even just models that were developed historically. So you're thinking about things like Google search. You have to ask yourself, who is represented in the data sets that they're using, right? So when you're looking at something like ChatGPT, right? They say, oh, we have this many billions of parameters. Well, what languages do you have in there? What have you done to actually look at the algorithm and understand or the data set and understand what it considers as normal? For example, does it make an association with parents as being two heterosexual parents or two heterosexual people? Does it allow for things outside of that? Because that can be baked into the way that the model works. Does it have an overrepresentation of certain identities in negative contexts? Because if it does, then it's going to learn that that is what those words mean. So for example, if all I did was scrape Reddit and I got a bunch of hate comments towards LGBTQ people inside of my data set, then it's going to authoritatively think those negative things about those groups. So what are they doing to look at and inspect that data to make sure that it's going to produce more equitable results? So I think it starts really on a technical level. Again, first framing the problem, how biased is that? But when you're collecting that data, you have to be really intentional about making sure that you're sampling it, pulling it together, examining it in a way so that you aren't automating something that's already harmful.
So one of the things we want to do is learn from the mistakes of the past. And you've got some great examples about, I think most of us here were around when the first search engines started to come online. Google was not the first.
Oh no,
I was a big
we all
fan
used
Alta Vista. And
oh geez, I was using, what was it? What was the one that came on when you logged into Juno? It was AOL, wasn't it?
AOL, yeah, I mean,
no, it was Yahoo maybe.
Might have been Yahoo.
Might have been Yahoo.
But like, so Google built, a pretty innovative search engine. It's obviously one of the most successful. But I mean, talk a little bit about how they built that first search engine and how they created that first index. And then what some of the natural biases that were built in there just because of what they built it from. Okay,
so I'm speaking as me, not as an official rep of Google. I'm not getting sued here. But when you think about it, one of the big things...
And this is historical, so...
Yeah, this is historical. And I mean, they talk about this openly, about how they went and built their first web crawlers and their algorithms for ranking and recommendation. So one of the big things that they did is they built these things called web crawlers that would go like a spider. They would go and they would go grab information from all the websites that were online, and they would create like this database or an index of that so that when you searched, right, it was like it had information about the sites to be able to pull up relevant results. And so over time, they started to build algorithms for ranking, for recommendation, ranking being what do I think, ranking basically takes and assigns a preference score to an item, right? So like, if I'm searching for mountain, right? What's the likelihood that I'm searching for Mountain Mike's Pizza versus a literal mountain I want to go climb versus the definition of a mountain? Well, that might be dependent on my context, right? Like, how often do I look up Mountain Mike's Pizza? How often do I look up a mountain? So it takes your individual context and then assigns an item a preference score, right? And then recommendation is where then it just puts those items in a list based on the highest preference score. And so as they built those algorithms and as the people using Google search were like, helping train the model by clicking different things and helping it understand what people actually want and preferred on a general level, we have to ask ourselves, whose data was represented in that process initially? Google was founded in 1998. I can tell you I did not have a computer in my household in 1998. We were extremely low income, let alone was I going to the library and going online to post my personal thoughts. That wasn't the purpose of the internet for me. It was MapQuest, 100%. I wanted to figure out how to get from A to B, right? And so when you think about the data that they were crawling and whose conversations and information was represented online, you have to understand that that overly represented one group of people. And the conversations that were happening on the internet at the time in a large capacity, unfortunately, were oftentimes folks who wanted to go online, share opinions that they did not want to be attached to their real life identities. So you had a lot of hate forums. You had a lot of forums that were online that were, promoting anti-Semitic behavior, racist behavior, homophobic behavior, sexist behavior, right? Because these are the things I can't say in real life, so the internet provided a space for people to go and be able to say that. So now you think about those people who, over that same period of time, are reinforcing that data, because they're the ones who continue to have access to it until maybe the mid-2000s, when it became more accessible, when people had Nokia phones with batteries that lasted long enough, right? And so what you now see in the industry in general is there are 3 different types of fairness techniques to deal with these types of biases that come up. The first is pre-processing fairness, which is where I'm going to try up front to mitigate as much bias as possible, doing things like balancing out my data sets, testing the model, right? You have in-processing fairness, which is while I'm training my model and while it's learning these associations, I'm going to manually go in and tweak it to undo some of this bias. And then you have post-processing fairness, which is also called fairness gerrymandering, which is, no, seriously, that's what they call it in the academic literature. And post-processing fairness is, I cannot fix my model. I don't want to fix my model, maybe. I don't know how to fix my model. So what I'm going to do is I'm going to adjust individual results. I'm going to adjust the output of it instead of fixing the way it fundamentally operates. So you may or may not see this very often inside of a company like Google, where people report very harmful results. Like, I remember a few years ago, there was a tweet that went viral from a Native American leader who had showed that you could type in the word Cherokee into image search and all it returned was Jeeps. And they said, why are you continuing to erase us? I wonder if they actually fixed the underlying algorithm or just changed that search results manually.
But people can search for it today and see what they get.
Oh, there's definitely going to be some actual Native American folks represented in there now, but did they actually fix the way the algorithm represented those people, or did they apply a policy to that query that makes it so that it forcefully shows those things?
What's the harm in doing that, though? Isn't that the appropriate response? Like, to see if we can't fix the whole system, we're going to fix this one small problem. What's the risk there?
I think that the risk there is that it's not just one small problem. That's just one manifestation of the larger problem. So now, for example, one of the challenges that you'll find in these tools is like, okay, let's say that I type in a college, like UC Berkeley basketball. It's always going to return the men's team first. Right? Now, you see that association of women sort of disappearing when searching for things like, who's the tennis champion with the most, or who's the tennis player with the most championships, and it returns the male, even though there's a woman who has more championships, right? So when you have this larger pattern of associations or behavior that's happening because of the way the algorithm was trained, and what you're doing instead of fixing that is you're chasing down individual places where it shows up, then it's a never-ending problem. And then also, you only are able to fix problems that people report. You have to know it's a problem to know to go fix that individual result, which is problematic because how many of you here know how to report a bad search result on Google? I see one hand, maybe 2, right? It's not, I mean, if you've ever like typed something, it's like there's a problem, report a problem with this, but that only pops up sometimes. Or you have to go to your settings and click things and go to it, right? So now imagine that you're typing something like, for example, there was this big blow up a few years ago where users were searching unprofessional hair. And in image search, it returned a bunch of pictures of black and brown people who had their hair in locks. And that got blown up, again on the media, but it got picked up by a very popular gossip blog called The Shade Room, which is like the TMZ, it's like an urban TMZ, and all the hoopla that came from that. The reality is search was functioning as it was supposed to, because image search doesn't actually search the images. What it does is it searches the titles of and the text of like the website, and then it returns those authoritatively. So what was actually happening was it wasn't Google saying this is unprofessional hair. It said, hey, it was all these like blogs people had written about like how I used to think my hair was unprofessional, right? But now I know that it's not, and I'm embracing my lock journey. But the challenge is, that's not what it feels like when you're searching for that, right? Mm-hmm. And so again, if you're doing post-processing fairness that requires, one, that you're even aware of what is harming people, which means that you have to have fallibility. You have to have the ability for people to actually report that to you very easily in context, which isn't available. And then two, you have to have the ability to address that harm. One of the things that I saw internally at Google, which was disheartening and a huge part of the reason why I'm glad I'm gone now, is that this was not heavily prioritized, right? Like you have a team that is, the trust and safety organization that has to deal with really complex issues, like things like child sexual abuse material, things like people literally posting murders on YouTube or physical violence on YouTube. You have to deal with policy violations. Now you're dealing with deep fakes. So whether or not the women's basketball team shows up might not be as much of a priority, even though that is causing harm. And so I think it becomes challenging to deal with these things. And I think the forcing function of how you make a company actually, I don't want to curse, but give a hoot, right, is that you have to have regulation. You have to have rules that force them to be accountable when these algorithms make harmful decisions so that they don't get away with just cherry picking what they fix at the end of the day.
Isn't the larger problem here that these tools are being trained on us? They're built. They're copying what we write. They're copying the patterns we have formed, and therefore it's natural to have these sort of reinforcements of these negative actions and negative associations. Like it learned it by watching us. How do we train something to be different than us when all it's got is us to train it?
So I think a big thing of it is who is us, because I wasn't on the internet at that time. And I hope it wouldn't be you either with some of the associations I saw there. That was terrible, right? And so I think the challenge is, and this is what Timnit Gebru talked about in that paper I mentioned last night, Stochastic Parrots. It's literally the research paper that she got fired from Google for. She was their head of ethical AI, the first black woman to get a PhD in computer science from Stanford. She and Joy Buolamwini birthed the field of AI fairness. And she got fired because she called this out. Whose worldview is represented? And this goes into that challenge of what we talked about lightly last night, of generalization. You might have a model that works really well for all those dudes who are on 4chan, but how does that model work well for me? How does that model work well for you? And then, how does that model work well and represent the worldview of people who are not even on the internet yet? We call those new internet users, which are the folks who are in rural America who still have 3G internet. The folks across, India, who are just now getting 3G internet. The folks in Nigeria. Nigeria alone has 300 million people. It's almost as big as us. Where in Nigeria, 1 gigabyte of internet on your cell phone costs half the national average salary. So I don't know if you guys have seen those memes where they're like, eventually everything's going to be a bundle package. We're going to get our Netflix and all this stuff with our cell phone package, right? Like the memes of where the future of tech is going, or like subscriptions is going. Well, that's actually how it works in Nigeria. You buy a cell phone plan, and there are certain apps that are bundled and included. Some of those apps do not include the social media platforms that we use. So where is their data being captured? And do we have the ability to capture it in their voice? When you think about the continent of Africa, there are thousands of languages, and some of them are purely tonal. There is no written equivalent. So how are we going to make sure that their voices are represented in the way that these algorithms work? Because if you have one algorithm that is supposed to stretch and scale across the globe, you have to have them represented. Otherwise, what you're doing is you're forcing one group's view of the world onto everyone else's normal, which is what we call symbolic power, the ability to define something and have everybody else accept it as normal. And if there's no accountability or responsibility or what's the word I want to say, or requirement for them to make sure that those associations are not harmful, are not doing things like authoritatively ranking anti-Semitic content, are not doing things like associating authoritatively LGBTQ people with pedophilia, overly sexualizing children, associating people with brown skin with primates or monkeys, things that we have all hopefully gotten over. So if these algorithms fundamentally function like that, and then we're stretching them around the globe, well, to me, it's no wonder why we're in a situation where you have certain resurgences of ideologies collectively in the United States that are leading to some of these things that were around when that my grandmother protested against coming right back and being in our faces again. I wonder how much the algorithms have a role to play in that, you know?
We got time for a question from the audience. Let's go right here up front.
Thanks so much for your comments today. And yesterday you gave us some hope, and you mentioned about these new platforms could really be unlocks to imagination and imagination writ large. Can you square these two for me? So I have this kind of dystopian view where we're going to do the whole thing again with kind of exclusion, if you will. And how do you see it shifting to where that, you know, there's no, everybody innately can imagine. And now we perhaps have the technology to allow that to happen. How do we avoid falling into the same trap, arguably, that we did in the last incarnation of technology?
Yeah,
Question make sense?
First and foremost, regulation. It wasn't until 2011 that the Department of Transportation required that crash test systems inside of cars, so like, you know, the little dummies that they have, it wasn't until 2011 that they required that automobile manufacturers test them with crash test dummies that were female-bodied. 2011. And up until that point, women were 60% more likely to be seriously harmed or injured if they were in a car accident where an airbag deployed. And you best believe that the automobile industry leading up to that was like, no, we got it, we can do it, right? Don't regulate us, we can figure it out ourselves. But that regulation has saved the lives of countless women today. Right? So having rules and guardrails is the biggest step, because forcing things like, you have to be able to explain to me that how your artificial intelligence made its decision, will then force the readjustment of resources towards the development of tools that makes this easier. But to answer another question, the other piece of your question is, oh my God, it feels like AI is going to be a super villain. Well, how's it going to be a superhero? I think that technology is the magic of our generation. It is the opportunity, especially right now with AI, the opportunity for us to either codify and automate and solidify the things we don't like about these systems, or the opportunity to completely shift them. An example positive from Google is an app that they released called Read Along. And at first it was called Bolo, but now it's called Read Along. It's a completely free app that's released in the App Store that basically allows a person, a student, an adult, to go to the app, to read out loud to it, and then the AI coaches it in real time. And so this app supports, like, I think almost 80 languages. Now, back in my undergraduate days, I ended up teaching at an elementary school, and I can't tell you how hard it was to teach one classroom of fourth graders where this person just immigrated to the US, speaks no English. This person has been here their whole life, but their household primarily speaks Spanish, so their English is weak. This person has a learning disability and can't read at the same level. And with statistics and things like 84% of black boys in the 6th grade and below are not reading at their grade level, or 300 million people in the world don't know how to read at all. Technologies like that become an equal playing field, where now it doesn't matter what kind of school district or what city or zip code I live in. If I have an Android phone and I can download that app, my kid can learn how to read and be coached personally, whether or not I can afford a tutor. So I think about technologies like that that can come in and really balance out the ways in which society has maybe created imbalance. Another example, a few years ago, I was at UC Berkeley on the Berkeley Forum, and there was a researcher at Stanford who talked about how they were creating algorithms for criminal justice that were opposite of, like, let's help the judges out, right? Like, where we're trying to assess and automate how long you should send in prison. And what they had done is they said, what are the biggest risk factors for somebody not showing up to court? And they figured out, like, okay, it's that they don't have transportation, they can't get time off work, or they can't get childcare. And they said, well, look, we can't babysit your kids, but we can probably help with the first two. So what they ended up doing was building an algorithm that created a risk score of the likelihood that you would miss because you couldn't get there, you didn't have transportation, or you didn't have, you might not be able to get time off work. And when it assessed that risk, they would send you a letter through the mail and through text message that you could show to your job to get time off work, and then they would offer you Lyft or Uber credits to be able to get to the courthouse and back. So these same technologies that we're using to think about automating existing functions can also fundamentally redesign the way that we're able to participate in society as a whole. It just takes different groups of people's imaginations being unlocked and then being able to access these tools to design those solutions. And I'll leave on this note. It's very easy to build something that works well for you. You have to be intentional about building something that works well for someone who is not you. And it's not just about diversity and inclusion in terms of race and identity and sexuality, because myself, I check just about every box. I'm Black, I'm Latina, I'm queer, I'm a military veteran. I give all the companies all the tax breaks, right? But the truth is, I cannot sit in a room and authoritatively represent the viewpoints of every single one of those identities. There are many different types of Latinos. There are many different opinions within the Black community. There are many different opinions amongst military veterans, amongst people who are differently abled, right? So it's not about let's make sure we have it. Part of it is, but it's not fully about let's make sure we have diverse groups of people, working on these products. It's about let's make sure that we are in touch with the people who can actually solve this problem. And the people who are closest to the problem are closest to the solution. So we have to start building and elevating continuous conversations with these groups of people to understand what it is that they need, how to represent that inside of our technology, and make sure that we build something that can scale. Scale across regulatory environments, scale across geographies, scale across communities, and scale within cultures.